Picture a night sky so vast it feels like an endless canvas, painted with countless stars twinkling like diamonds scattered across velvet. Among them, one shines with a quiet, steadfast glow, a celestial guide that has whispered directions to sailors, explorers, and dreamers for centuries. This is Polaris, the North Star, a beacon of constancy in a universe of motion. But hold on, whispers from the cosmos suggest something peculiar is stirring with our trusty guide. What's the buzz about Polaris lately? Let's embark on a starry adventure to uncover the secrets astronomers are unraveling about this iconic star. Polaris, or Alpha Ursae Minoris to the astronomers, or Alpha Michigan if you're feeling fancy, isn't the brightest star in the sky. It's the 48th, to be precise. Yet, its soft, yellowish glow holds a magnetic charm. For ages, it's been the go-to point for navigating oceans and uncharted lands.
Why?
Because it sits almost perfectly aligned with Earth's rotational axis, an invisible line stretching from the North Pole to the South Pole. Imagine Earth as a spinning globe, and Polaris is the one star that seems to stand still, a cosmic anchor while the rest of the heavens whirl around it in a dazzling dance. Isn't it wild to think one star could hold such power over our journeys? But here's where it gets fascinating. Earth isn't a perfect spinning top. It wobbles, ever so slightly, like a toy slowing down. This wobble, called axial precession, is a task. I'm no scientist, but I can tell you it's caused by the gravitational tugs of the sun and moon. Over 26,000 years, this wobble traces a slow circle in the sky, shifting the point where Earth's axis aims. The result? The North Star's position isn't forever. Right now, Polaris reigns supreme, but in about 13,000 years, the brilliant Vega will steal the crown. Can you imagine a world where sailors look to a different star? This cosmic shuffle has a name: stellar precession. Rewind to 3000 BC, when the pyramids rose in Egypt, and a dim star called Thuban in the Draco constellation played the North Star's role. By 500 AD, Polaris took over, and it's creeping closer to true north, set to align perfectly in 2102 before drifting away again. By 3000 AD, it'll still be the closest star to the North Pole, but the sky will look a little different. Isn't it humbling to think the stars themselves shift roles over time? Now, you might be wondering, how do I spot this legendary star? Well, that depends on where you call home. In some parts of the world, Polaris hides below the horizon, out of sight. But if you're in the northern hemisphere, it's like a cosmic landmark waiting for you. If you're a fan of our channel, you're probably no stranger to constellations, those starry patterns that spark stories of gods, heroes, and creatures. Polaris sits at the tip of the Little Dipper's handle, a guidepost in the sky's grand tapestry. So, what's this strange new chapter in Polaris's story? Astronomers are buzzing with reports of unexpected changes, and we're diving deep to find out what's happening. Imagine standing under a starlit sky, the universe unfolding above you like a cosmic map. You're about to become the star of your next stargazing adventure, dazzling friends and family with your newfound skill to pinpoint Polaris, the North Star. Ready to unlock the secrets of the constellations? Let's dive into the celestial treasure hunt to locate this legendary beacon, with a few tricks that make it as fun as it is rewarding. The easiest way to find Polaris is by tracking down the Big Dipper, a constellation so iconic it's like the night sky's signature. Picture 7 bright stars forming a ladle, its bowl ready to scoop up the wonders of the cosmos. It's one of the first patterns stargazers learn to spot, glowing boldly against the dark. Focus on the 2 stars at the end of the bowl, opposite the handle, Merak and Dubhe, the pointer stars. These trusty guides are your cosmic compass, pointing straight toward Polaris. Can you see them twinkling, ready to lead the way? Here's the trick. Measure the distance between Merak and Dubhe with your eyes, then imagine stretching that line outward about 5 times its length. Follow it through the sky, and there it is, a moderately bright star with a soft, yellowish glow. That's Polaris, standing proud as the North Star. Not sure you've got it? Look to the left and hunt for the Little Dipper, a fainter constellation that mirrors its bigger sibling but often plays hide-and-seek in the sky. Its handle curves gently, and at the very tip, you'll find Polaris, shining like a lighthouse in the cosmic sea. Now, some of you might be thinking, why not just find the Little Dipper first? Fair question. But the Little Dipper can be elusive, its stars dimmer and harder to trace, especially on a hazy night. The Big Dipper, bold and unmistakable, is your reliable starting point. Picture the Little Dipper hanging upside down, its bowl dipping toward the heavens, a mirror image of its larger counterpart. Confirm these patterns, and congratulations, you've just claimed Polaris as your own. But here's a catch, not everyone can spot Polaris. If you're near the equator, it hovers right on the horizon, teasingly out of reach. Venture into the southern hemisphere, and Polaris slips below the horizon entirely, invisible to the naked eye. Where are you stargazing from tonight? Your location might just determine whether this cosmic guide winks back at you. Now, brace yourself for a mind-blowing fact about Polaris that you'd never guess without a telescope. This isn't just one star, it's a stellar family. Polaris A, the main act, is a supergiant, a whopping 4.5 times the mass of our Sun, stretching nearly 28 million miles across. It's a Cepheid variable, a star that pulses like a cosmic heartbeat, shifting in size, temperature, and brightness. Astronomers call these standard candles, because their predictable pulses help measure vast distances in space. At 445.5 light-years away, Polaris is the closest of its kind, making it a celestial celebrity. Orbiting this giant are two smaller companions, Polaris B and Polaris AB, dancing at distances of 2,418,000 astronomical units, respectively. You'll need a powerful telescope to catch a glimpse of these shy siblings, but knowing there adds a layer of magic to Polaris's glow. And speaking of magic, NASA's Chandra X-ray Observatory captured a jaw-dropping image of Polaris, revealing its fiery heart in stunning detail. Zoom out, and the star's surroundings come alive, a cosmic neighborhood sparkling with secrets. As we linger on this breathtaking view, the story of Polaris is far from over. What mysteries lie in its pulsing light and distant companions? Gaze up at the night sky, and imagine a delicate veil shimmering around Polaris, not clouds from our Earth, but something far grander, an integrated flux nebula. This ethereal cloud, woven from dust, hydrogen, and carbon monoxide, glows faintly, creating a celestial backdrop that seems to cradle the North Star. But here's the twist. This nebula isn't cozying up to Polaris, it's far behind, drifting beyond the Milky Way's bustling galactic plane. What makes it truly mesmerizing? It's not lit by Polaris alone, but by the collective radiance of every star in our galaxy, a cosmic glow that paints the heavens. Can you picture that, a nebula glowing with the light of a billion stars? Now that you're practically a cosmic scholar on Polaris, let's dive into the mystery that's got astronomers buzzing. Something strange is afoot with our North Star, and it's challenging everything we thought we knew. The trouble? Pinpointing exactly how far Polaris is from Earth. This star, our steadfast guide, is playing hard to get, breaking the rules of how stars are supposed to behave and leaving scientists scratching their heads. Astronomers have a toolbox of methods to measure a star's distance, mass, and age, and one of their go-to techniques is the stellar evolution model. By studying a star's brightness, color, and pulsation rate, they can piece together its life story. How big it is, how bright it shines, and where it sits in the vast cosmic timeline. For Cepheid variable stars like Polaris, this method is usually a slam dunk. Their pulsations, like a cosmic metronome, are directly tied to their brightness, making distance calculations a breeze. When Polaris pulses, it swells and shrinks, its helium-rich atmosphere soaking up energy. Bigger means brighter. Smaller means dimmer. Simple, right? This rhythmic dance was first spotted in 1911 by Danish astronomer Ejner Hertzsprung, whose name alone sounds like a star in its own right. For over a century, Polaris kept a steady beat, pulsing every 4 days like clockwork. But something's changed. Since 2010, astronomers have noticed the unexpected. Polaris's pulsation periods, which had been stretching by 4 to 5 seconds each year for over 150 years, have suddenly reversed course. Why would a star so predictable suddenly change its tune? Could the answer lie in Polaris's cosmic companions? Polaris B, orbiting every 30 years, might be stirring up the star's outer layers, where these pulsations take place, like a pebble rippling a pond. But there's a wilder theory, a cosmic plot twist. Some scientists wonder if Polaris itself is the result of a stellar collision, two stars smashing together millions of years ago. Imagine the chaos, a cataclysmic merger that infused Polaris with fresh material, making it appear younger, like a star sipping from a celestial fountain of youth. The catch? Such a collision doesn't neatly fit the stellar evolution models astronomers rely on. It's a long shot, but in the vastness of the universe, who's to say what's impossible? As we marvel at Polaris's defiance of our expectations, the North Star's story grows ever more intriguing. What other secrets does this celestial beacon hold? Picture Polaris, our steadfast North Star, glowing like a cosmic lighthouse in the night sky. Just when we thought we knew its secrets, a new discovery has astronomers buzzing with excitement. Like Earth, with its magnetic field guiding compasses, stars too can hum with magnetic energy, driven by the swirling dance of charged particles deep within. This process, called a convective dynamo, churns inside stars, creating invisible forces that shape their behavior. Think of our sun's sunspots and solar flares, vivid proof of a magnetic field at work. But for Polaris, a Cepheid variable star, something extraordinary was uncovered in 2022. Could this be the key to unraveling its strange pulsations? At Queen's University in Kingston, Canada, researchers made a groundbreaking find. Polaris has a magnetic field, a rare and remarkable feature for a Cepheid star. For years, these fields were invisible, masked by the star's rhythmic swelling and shrinking. This magnetic discovery is like finding a hidden gear in a cosmic clock, influencing how Polaris evolves. It tugs at charged particles in the star's atmosphere, tweaks its stellar winds, and might even slow its spin or reshape its core. Isn't it wild to think a star's magnetic hum could hold such power? This finding could explain why Polaris's pulsations have been acting so unpredictably, shifting from a steady 4-day rhythm to something less certain. Magnetic forces might be stirring the star's outer layers, like ripples on a lake, disrupting its cosmic beat. But studying these fields is no easy task. Cepheid stars, with their constant pulsing, are notoriously tricky to analyze. Yet, understanding Polaris's magnetic field could unlock deeper truths about the universe itself, a bold claim, but one that sparks the imagination. The team behind this discovery is hard at work, racing to map Polaris's magnetic field with every glimpse they get as the star rotates into view. Each observation is a piece of the puzzle, revealing more about our celestial guide. What will they uncover next? The universe, it seems, loves to keep us guessing. The more we learn about Polaris, the more it reminds us how vast and mysterious the cosmos remains. As we marvel at this starry enigma, there's more to explore about the North Star's place in our skies and its secrets yet to be revealed. Stay with us as we journey deeper into the universe, where new discoveries await to light up your curiosity.